This is your homework solutions. I know that there's going to be needed for support, right? So it's really important that you listen and that you're learning and not just finishing your work. And sometimes it's hard to do that. But I want you to try your best. So let me try my best to explain it to you. We're graphing this equation, x plus 3 over x minus 2. Step one is there anything that's factorable? And there isn't. The top and the bottom are prime. There's nothing we can factor. It is what it is. So the x-intercept, I look at the numerator, the top, and I say, what's the 0 of the top? And it's the opposite number from what I see, so it's negative 3. So when I go to the graph, go to negative 3 and you have a point. The next is the vertical asymptote. I'm going to do this with color. That's the 0 of the denominator. So the opposite number, that's going to be x equals positive 2. So start in the middle, go 2 to the right, and draw a vertical line through 2. Next is the horizontal asymptote. That's found by taking the power term of the top and the power term of the bottom and dividing. So the power term is the term with the biggest exponent. So x divided by x, when I divide that, that gives me the horizontal asymptote 1. So I start at 1, so that means I go up 1, and then draw a horizontal line over 1. We have no hole because nothing crossed out. Our domain is what x can't be from the denominator, the asymptote, which is 2, and the range is what y can't be from the horizontal, that's 1. And then I'm going to draw this. Now there's one thing I'm going to find that's not over here, which is the y-intercept. So to find the y-intercept, you plug in 0 for x and you solve it. So it's 0 plus 3, 0 take away 2, and then you solve that. So 3 divided by negative 2 is negative 1.5, and that's going to go on my graph too. Now, I'm going to connect these points together and curve it, and it's going to curve down towards the asymptote, and it's going to curve up but be very flat. It doesn't touch or cross, so it curves up and it's going to like follow that. There's another curve on the right side. So the asymptote is at 2. I'm going to pick the number to the right of 2 to get a point that I can curve through. So I'm going to pick 3, and I'm going to solve it. So 3 plus 3, I'm going back to the equation. I take out the x, put in 3. Same for the bottom, put in 3 and solve it. So 3 plus 3 is 6. 3 take away 2 is 1. Divide, and you have another point to curve through. So I go to 3 and 6. And then this curves the end. So this goes to that asymptote, it curves, this goes to that asymptote, and you're done. The end behavior here always goes to the horizontal asymptote. So as x approaches infinity, f at x approaches, what number is our horizontal asymptote? That gives me the end behavior, 1, for both directions. So also the left end behavior also is approaching 1. So if you look at the arrow on the right and left, it's getting closer and closer to 1. All right, number 2. Again, it's okay if you have to follow what I'm doing, but try your best first. Step 1 is to factor. So if you press pause and try to factor, what would it look like? So I'm going to factor out a common factor. So 4 is a number that goes into both. So 4 divided by 4 and 4 divided by 24, that's what's left over. I'm going to do the same thing here. I'm going to factor out a 2. And then what's left over is x minus 2. I'm going to simplify it. So 2 goes into 4 evenly. That does not create a hole because no letters were crossed out. And this is what I'm going to graph. So the 0 comes from the top. So the opposite number of x minus 6 is 6. The vertical asymptote is in the denominator. The opposite number, that's 2. That's my domain as well. The horizontal comes from, and you can start at the beginning or the end. They'll all give you the same answer. If you want the power term divided by the power term, what's 4x divided by 2x? The x's cross out, 4 divided by 2. The horizontal, when you divide, is also 2, also the range, and there's no hole in this graph. So this is what I'm going to graph. So I have my red pen, so I might as well draw the lines. There's the vertical and horizontal. Both are at 2. Then we have a point at 6. Oh, I counted from the wrong spot. Again, I'm going to find the y-intercept. So to find the y-intercept, you plug in 0 for x and then solve it. The easiest actually is to go back to the beginning, and it's always the last numbers. When you plug in 0, what's the last number? When you plug in 0, what's the last number? And then divide and you get your answer. So it's 6. And now I can draw the curves that I need to draw. And we're done. Number 3. Try it first. So first we need a factor. So the numerator is a one-step diamond, really simple. Two numbers that multiply to 10 and add to 7 are 5 and 2. So the domain is x can equal 5, negative 5. That comes from the denominator. These cross out, and that leaves me with x plus 2 over 1, or x plus 2. What crossed out? X plus 5. We're going to make equal to 0 and solve it. So we're going to subtract 5 to both sides, and x is equal to negative 5. That's the whole. But the whole also has a y value. So to find the y value, I plug in negative 5 for x and solve it. So negative 5 plus 2, and I get the answer negative 3. Oh, I messed up my color coding. All right, negative 5, 1, 2, 3, 4, 5, and negative 3. There's my whole. Now, my x-intercept is negative 2, the opposite number there. We have no vertical and we have no horizontal. This is a line with a hole in it. And the range is going to be the y-coordinate of the hole. So the x-intercept's at negative 2. And then I draw a line through that. Hop over the hole, and there's the picture. Oh, you know what I forgot? In number 2, the end behavior, right? So the right end and the left end both go to the same number. So for number 2, it's the horizontal, which is 2. For this one, the right end goes up, and the left end goes down. So when you don't have a horizontal asymptote, then the ends either go up or down forever. All right, let's look at number 4. Step 1 in number 4 is to factor it. So I have x plus 3. The denominator is called the difference of squares. So we're going to square root it. So we have x plus 3 and x minus 3. So there's two numbers x cannot be. So if I look at the denominator, the two numbers are negative 3 and positive 3. Then I can cross them out, and I'm left with 1 over x minus 3. So I crossed out x plus 3, make that equal to 0, subtract 3 and solve it. That's the whole, the domain restriction. Then to find the y value, you take negative 3 and you plug it back in. I get a small fraction. It's negative 1 over 6. So if we put that on our graph, we'd go to negative 3 and negative 1/6. Just below there we have a hole. We have, if I look at the numerator, I have no x-intercept. Nothing makes that 0. The denominator, I have a vertical asymptote at positive 3. So I'm going to go to positive 3 and draw vertical asymptote. I have a horizontal. No, the numerator is smaller than the denominator. So the degree on top is 1. The degree on the bottom is 2. If the degree on the bottom is bigger, then we have a horizontal asymptote at 0. We could say the two numbers y can't be are 0 and negative 1/6. I am going to find the y-intercept. So if I plug in 0 for x, I got 1 over negative 3. And I'm going to put that on my graph. So I'm going to connect these together. And so I have my graph on this side, but I need the curve on the right side. So the asymptote is at 3. So I'm going to pick a number to the right of 3. And I'm going to plug that in. So I'm going to plug in 4. So if I plug in 4, 4 take away 3 is 1, and divide, I get the answer 1. So go to 4 and 1, and then we can draw this part of the graph. It's really a reciprocal with a hole in it, and it's done. The end behavior, the right end and the left end are going to 0, the k value. All right, a few more left here. We're almost there. Number 5. We're going to factor it. So we're going to factor out an x. This is a simple one-step diamond, positive 4 and negative 1. So the two numbers x can't be are negative 4 and positive 1 from the denominator. These cross out. It leaves me with x over x minus 1. So what crossed out, you make equal to 0 and solve. To find the y-coordinate of the hole, you take that answer, negative 4, and plug it in. So it's negative 4 over negative 4, take away 1. That gives me a positive answer. So a negative divided by a negative gives me positive 4 over 5. So we can put that on our graph. Not quite 1. We have an x-intercept up here. X gives me an x-intercept of 0. The vertical asymptote from the bottom is x equals positive 1, the 0 of the denominator. If I look at the power terms and I go x squared divided by x squared, that gives me 1. That's above the hole and above the point. And that also would mean the range of what y can equal, 4/5. So positive 1 and 4/5, the y values. All right, draw the curve here, connect the hole and the point, and the ends go to the asymptotes. We need a point on the right to curve through, so the asymptote is at 1. So a number 1 bigger than 1, we're going to plug in 2. So it's 2 over 2 minus 1. So when you solve it, the answer is 2. So go 2 to the right and 2 up, and then you have the other picture as it goes to infinity and to the horizontal asymptote. The end behavior is the horizontal asymptote, which is at 1. Number 6. Let's factor this. This is going to be one again that's not from our lesson. It's actually one for the next lesson. So this is what I'm going to do. I'll do it. But I'm just saying that this is not a question from this lesson. So the degree on top is 1 bigger. There's no hole in it. It's going to create an oblique asymptote. So I'm going to give you a preview. So we factor and I preview. So we have intercepts at 3 and 2 and negative 2. So I'll do that. 1, 2, 3, and negative 2. We have a vertical asymptote at 0. We have no horizontal. We're going to call it an oblique asymptote in the next one. And we find that by dividing. And this part doesn't matter. So it's y equals x minus 1. So I'm going to start at negative 1 and go up 1 and over 1. The vertical is at 1, so it's over here, over 1. So we have a slanted and a vertical with no horizontal. And then the ends go to the asymptote through those 2 points. So it has a very different look to it, right? There's no hole. The domain, x can't be 0. And believe it or not, the range is all numbers because of the way the curve goes from the bottom to the top. It covers all the numbers. So that's a preview. I'm not going to let you. The quiz on this lesson is not going to cover that, but the next one will. All right, last one, number 7. Factor this. So the top, we have to do some top. First, multiply the second, last, and negative 5. The two numbers are negative 6 and 1. Divide by 3. So I have x minus 2 and 3x plus 1. The bottom, the two numbers that multiply to 2 and add to negative 3 are negative 2 and negative 1. So our domain can't be 2 or 1 from the denominator. x minus 2 does cross out. That leaves me with this. If you take what crossed out equal to 0, that's the x coordinate of your hole. To find the y coordinate, you plug in 2 for x and you solve it. So in this case, you get 3 times 2 plus 1 divided by 1. So that's a nice hole at 2, 7. So we're going to go 2 to the right and 7 up. All right, the denominator and numerator. So the numerator, the intercept's negative 1/3. Go back a step to the fraction. So I'll approximate where negative 1/3 is. That's it. The vertical asymptote is at the bottom there, the 0, which is at 1. The horizontal, if I go the power term over the power term and divide, I'm left with 3. So I'm going to go 1, 2, 3. And then I'm going to use the hole to curve, and I'm going to use this point to curve. The y-intercept, which I like, when you plug in 0, you have 1 divided by negative 1. So you have a nice point for the y-intercept, which is negative 1. So that's nice to have an extra point to curve through. And then the end behavior. So this, the range, is the horizontal and the y-coordinate of the hole, and the end behavior. So the right end and the left end go to the horizontal, which is 3. This was a really strong lesson, right, and homework, and I appreciate you working through this. The truth is, you're probably going to have to take a piece of graph paper out and do it a second time and really go through, like now that you've gone through it with me, what would happen if you wrote that question on a piece of graph paper and you tried to graph it without my video and then watch it and then work at it until you get it? All right, Mr. G Math over and out. Till next time.